Welcome back to Forensic Lectures. In this video lecture, we are going to see spectroscopy. So what we will cover today is that different types of spectroscopy, that is UV, visible, IR, Raman spectroscopy, atomic absorption, and also the atomic emission spectroscopy. So let us first see what is the visible light spectroscopy. So it is nothing but a quantitative technique or a quantitative analysis. Okay, it is used to measure how much chemical substance it absorbs, or we can say the light absorbs. This is done by measuring what the intensity of the light that is passed through a sample with respect to the intensity of light through a reference sample or a blank. So if we take the example of a sample that is the H2O, so what light is passed, if we pass a light, then how much light is absorbed and how much is given out, that is measured here. Okay, so it is a sensitive technique, or you can say a accurate method of measuring the color or mixture of colors that our eyes perceive, and removes the obvious subjectivity and visual anomalies associated with the human vision. So as like now I am using here the red color, so red color marker, right? So you can see this color as red, but certain people, they are colorblind to certain colors, they cannot see. Same way, whatever is visible to our eyes, that are seen by us, right? We can we have the example of IR radiation that are not visible to our eyes, right? We need certain filters to make them visible. So here, whatever that is visible to our eyes, that whatever we can see through our eyes, whatever color we can differentiate through our eyes, that are seen or that can be analyzed in this technique. For analyzing that type of colors or the mixture of colors, we say it is the visible light spectroscopy, and it is used to analyze the chemical properties, like what is the structure, what are the chemical properties, like melting point, boiling point, like different types of chemical properties of that material. It can be used to determine concentration, like here in H2O, if I mix H2SO4, that is a solution, a chemical solution, then it can also give us in how much concentration this both solution are present. It also identify unknown compound. So whenever we say an unknown compound, then it comes under the forensic part, right? Means we are finding something which is unknown to that particular case, right? So it provide information about the physical and the electronic structure. So like different chemicals, they have different chemical structure, right? So it gives us the physical as well as the electronic structure of whom the organic and also the inorganic compounds. Okay, so let us see the UV spectroscopy. So UV is what? Ultraviolet spectroscopy. So it has certain radiation, like I have told you the range, right? In a spectrum, electromagnetic spectrum, there is a range, right? Here it will be UV or visible, like somewhere, right? So what happens here is that it is a part of electromagnetic spectrum. Then we have the UV, that is from ranging from 10 nanometers to 400 nanometer. Okay, in the electromagnetic radiation, that is shorter than the visible light and longer than the X-ray and infrared light. So UV radiation, they has these three part, that is first is short, medium and the long. So in the short, what is it range is that from 180 nanometer to 280. Then in the medium, it is from 280 to 320. So this is used many a time, like wave, like UV, it is like Corta's lens which is there, no? They produce this. Then the longest or the long wavelength is from 320 to 400 nanometer. Like it is known as the near ultraviolet. Okay, and this region produces by a portable lamps. So they can be very beneficial in forensic expert for document examination. Then the ultraviolet light techniques which are there, it is used for multiple times in forensic like investigation including like authenticating paints, right? Art, like different types of arts they do this forgeries, like paintings forgeries, right? So here detect the type of inks which is there, the analyzing question document, eliminating latent fingerprint. Okay, then clothing, evidence on clothing, ink stain, or also some residual body fluid stains they can identify. Then also they have like technology like monochromators, ultraviolet monochromators are there, or optical spectroscopy. It uses to detect the presence of an illegal or a controlled substances or a residue in unidentified sample. Or it can also determine how many types of ink pens were used in a forged document. Like here if you have a forged documents, then the original writer will I'll give you a simple example, will use a ball pen. Okay, so same ball pen has many companies, right? Cello, then this other companies are also there. So here what happens, when you are using, you will use like we have some certain rules, like everything is uniqueness, right? So even if you are using that ball pen only, means the other type of, then the time or the location, certain thing will differ, so they can be identified over here. Then detection of forgeries in document under long and short wavelength light usually examine several document in question. Okay, so next application, just now we have seen, right, uses. Then what it says in the examination of ink, like different papers, and also in this it is very much used in this counterfeit currencies, right? This is a scam going on, right? In many parts of India also right now. So they identified the counterfeit document or counterfeit currencies, like they determine the fluorescence. I will make a separate video means on the currency, what are the features of that which makes it a real currency. Then authenticating documents, like they have sizing king, okay, which type of fibers, watermarks, all this we can discuss in the video lecture, special video lecture that will be based on this document. Okay, then printing duplication can also be determined. Okay, generally following types of documents are prepared in duplicate or fake currency note: security paper, passports, certificates. Like many people they make the fake passport, right? That cases are also there. So next, moving on to the infrared radiation, that is the IR spectroscopy. So in this, IR is the electromagnetic radiation uh, that with longer wavelength than the visible light. So therefore it's generally invisible to the human eye. So this IR radiation which are there, they are not visible to the human eye, although it can be felt as heat by human. So the sun which gives us this IR radiation in the form of heat which we can feel, they are the IR radiation. Okay, so IR wavelength they extend at 700 nanometer from the nominal red edge of the visible spectrum to 1 millimeter. Okay, so most of the thermal radiation that are emitted by an object near in the room temperature is infrared. Okay, like anything. Okay, you are heating water, okay, over a gas. So whatever the heat and energy it is generating, first it is like in the form of IR radiation. So the most characteristic feature of this IR rays is that they are readily absorbed and converted into the heat energy. So unlike this, UV is does not have any fluorescent effect and cannot be viewed by the unaided eye. So UV, like blue color filters, we can easily see, right? So this IR, they are unaided. Without it, you cannot see them. So the basic source of this IR radiation forensic is work is like 1000-watt tungsten lamp. So this is the basic source which is used in forensic science. Okay, so the various filters are needed to screen out the light waves and to allow only IR rays to pass through it. So for this IR spectroscopy we need certain types of screens, okay, that will only allow the IR, means visible a light will have different regions, right? Like UV visible, so only a filter will pass only the IR light through it. So next is, it is also same used like the UV only, like analysis of being examination of erasures is nothing but a type of forgery after, like we erase something, right only. Cancellation mark, examine fibers also, like blood stain also, they also see this dry and wet blood stain. It, like here in blood stain what happens is that they determine the enzyme activity in a stain. So if the enzyme activity is going on, they determine that. And like in thin layer chromatography, right, it is a complementary method. Okay, so with spectroscopy the trace evidence including the hair, fiber or anything can be easily analyzed with high accuracy. Next, the Raman spectroscopy. So in Raman spectroscopy, what happens is that is a type, it was given by Raman. Okay, so most of these light sources, they are all non-destructive in nature. Okay, so this is a non-destructive chemical analysis technique which is used to analyze vibrational, rotational and other low frequency modes in a system, providing informations about the chemical structure, crystallinity and molecular interaction. So these are highly chemistry word, right? So it determines all this activity. So when a monochromatic beam is passed through this, a scatterer or a liquid gas or a solid, small friction of light is scattered due to the collision between the molecule substance and photons of the light. So we have this monochromator is a device. Okay, so on the basis of principle we will be able to understand it more briefly, that it shifts the wavelength of an inelastically scattered radiation that provides the chemical and the structural information. So these shifted photons can be either of higher or lower energy depending upon the vibrational state of the molecule under study. So okay, in simple words I will explain you here is that, like we have a particular, we can say here is the ground state of the electron. So when it gets excited, it will move to the highest energy level. So but whenever it is coming down, in Raman spectroscopy what will happen, it will move to the, this will be ground state. Okay, this is ground state, this is the first state. Okay, so it will come here. So that how it works. So here you can see it is the shift in wavelength of inelastically scattering radiation that provides chemical and structural information. If the shifted photon can be either of higher or lower energy depending upon the vibrational state of the molecule under study. So both this molecule, they will have different levels where they can come. So depending on the levels we can identify the different nature of this chemical compound. So when the light which interacts with molecule in a gas or liquid or the solid, the vast majority of the photons are disappeared or scattered at the same energy as the incident photon. So what happens here, this is the thing I have explained. So as the scattering happens, this described as elastic scattering or Rayleigh scattering. Okay, whenever all this get excited, that is Rayleigh scattering. A small number of these photons which are there, they approximately like one photon in 10 million. So see, in 10 million only one photon will be scattered, that will be at a different frequency than the incident photon. And this process, whole process is known as what, inelastic scattering or the Raman effect. Just see here, okay, a common this is the ground state of the, this is the ground state of any photon or electrons. Okay, so all these photons will move to an excited state. Only they will come back to the same energy level. But what will happen, one will be there, like in 10 million only one which will come on this original. So this Raman allows the user to collect vibrational signature of the molecule, giving insight into how it is put together as well as how it interacts with other molecules around it. So the parts in this Raman spectroscopy are which the source means what, like the spectrometer and like the laser. Okay, so mainly this laser only is used because it gives high intensity. Okay, so this scattering is produced, so that this high energy scattering which is that is only necessary, or it is more important in this Raman spectroscopy. It can be measured with reasonable signal to noise ratio, like argon ion laser is one example, krypton ion laser, then helium neon. Okay, these are the sources. Then the sample, which is sample illumination system, which will be there, which will be handling the sample, okay, for Raman spectroscopic measurement. So it is simpler than the IR spectroscopy. The laser source is easily focused on a small sample area. Consequently, a small sample can be detected. Okay, even 0.05 grams of sample also can be detected in this Raman spectroscopy. Then the detector which is there, it will detect and send a signal. So there will be a computer attached to this system. So here they will produce in a bar graph what amount of substance is there. Then the atomic absorption spectroscopy. So this here it is also an analytical technique. It is used to determine how much of certain elements are in a sample. So all this I have said, they are quantitative method. So it uses the principle that atoms, or you can say the ions, they can absorb light at a specific or unique wavelength. So when this specific wavelength is reached or provided to them, the energy is absorbed by the atom. So each atom, they absorb this particular energy, like uniqueness, right? Unique principle. So again we are moving there only. So in this absorption spectroscopy, it is employed as an analytical chemistry tool to determine the presence of particular substance in a sample, in many cases to quantify the amount of substance present. Like in water, in a glass of water, you can say how many hydrogen molecules are there or how many oxygen molecule are there, they can be determined over here, or any other chemical compound we can take. Okay, then the atomic emission spectroscopy. So in this what happens is that it is also same way, but here there is absorption energy is recorded, here the emission energy is recorded. So it is a analytical method only. Quantity it uses in the intensity of light emitted from the flame, plasma or arc or a spark at a particular wavelength to determine the quantity of an element in a sample. So here atom is there, so at per certain wavelength it will emit energy. Okay, so that is measured in emission spectroscopy. In absorption, what happens at certain wavelength, this will absorb the energy, so that is measured. Okay, so instrumentation for me, it is like it has the sampling device, a source, a spectrometer and a detector and a readout device. Okay, then the principle here is that atomic emission spectroscopy, the energy is applied to a molecule in the form of light heat. Okay, light or heat, anything, it can be. The energy then excites the electrons in the molecule to higher energy level, and in the excited state, what happens is that the atoms which are there, they become less stable. So whenever you are shifted from, like your whenever you are moving from your comfort zone to another place, you become a little unstable, right, at a particular time. So there will be less stable, and the ground state of an atom, so this then the ground state. Okay, so this will result in decay of the excited state. Just like here there are certain levels, energy levels. Okay, so what happens, this will be the ground state. So from here they are excited to a certain level. So whenever, if you have been stopped at the stage 1, okay, so there here this atom will be unstable, there where this spectroscopy takes place. Okay, then the uses of this both spectroscopy is that This atomic absorption, this can be used to do the in-depth analysis of blood sample, brain and muscle tissues, okay, and also the gunshot powder residue, the GSR. Then it is used in food and beverages, water, clinical research, also in pharmaceutical, means the chemical analysis. Then the atomic emission, what are its uses also same like they will determine the metal, metalloid, some non-metal, okay, simultaneously. And also it is used to monitor the level of different chemicals and trace element in an environment, and to determine the composition of solid, liquid and gases. So that's all for today. Thank you. If you like this lecture, do like, share, subscribe and comment. Thank you.